sophomore design distortion pedal team, here to talk about our project today.
Hello, everybody. My name is Jason Bradford, and I am also with the Distortion guitar pedal team. We'll go over the design today.
Hello, I am Zaid, and I will go over the design as well. So we're using a distortion pedal, and what we're making is one of the many pedals that electric guitars use to control the signal and alter the sound. The distortion pedal that we're working on has three knobs: the gain, tone, and level. So based on the gain, the amount of clipping that occurs at the diodes determines the distortion. The distortion is a gritty, harsh sound. So there are many ways that we have tested our design and then got to build it. Jason will go over that.
All right. So for the design process of the distortion guitar pedal, we started using LT Spice and MATLAB Simulink. This was to simulate a circuit that used the input and output buffers of the Boss DS1 distortion pedal, and then use the gain, level, and tone stages in the Proco Rat distortion pedal. After we simulated this, we then used Eagle as a prototype of the breadboard circuit to make the process of breadboarding more simple. So the results of the breadboard were then tested using an oscilloscope and then the other things. And then with this, we compared the waveforms of the audio signal with that of what we simulated in LT Spice and MATLAB in order to verify that you're getting the correct output for the distortion guitar pedal.
All right, so I'm going to talk a little bit about the experimental results we obtained. So as you can see under the experimental results section, we have a few figures to compare. So on the left, what you're going to see is the output that we recorded from the oscilloscope from the breadboard circuit, and on the right is the results from the LT Spice simulation. And so what you can see is that as the signal comes out of the gain clipping stage, it has a nice square waveform, and that's due to the clipping action of the diodes. They essentially cut off that part of that sinusoidal wave, at a certain level, which would be the forward bias voltage of the diodes. Then essentially, as that signal moves into the tone stage, the variable nature of that potentiometer in conjunction with the capacitor creates a filter, and essentially what that does is that it alters the frequency domain of that signal and moves it from that nice square clip waveform into a more sawtooth waveform as that potentiometer is altered. And then so finally, what you can see is the output of the whole circuit being measured, and that was at the very end of the output, essentially what you would see at the end of that audio jack. And so for that stage, what we tested in LT Spice was the tone and the level potentiometers were both set at about 50%. Then the distortion potentiometer was varied from 0 to about 50% to a full distortion. And so as you can see, essentially the signal, it's going to be sawtooth in every case. However, the frequency domain of that signal is altered as that tone or that clipping potentiometer is varied. And so essentially, you're going to get a slightly different sounding signal as you vary that distortion potentiometer.
So we will show the PCB build that we have and the output of it.
All right, so what you can see here is actually the prototype PCB setup that we're testing. So as you can see, we have our bottom board on the bottom there, and then our top board, which has all our potentiometers on it, and then our 3-pole double throw switch. And then on the left, you can see the output waveform of the tone. All right, and so here you can see the actual enclosure that we're going to use for our guitar pedal for the final design. And so as you can see, it has a kind of a slope design, which is something new that we thought was kind of interesting to put into a guitar pedal. Really, it's just a solid setup that we think will lead to a really clean looking and slick design.